Let's just look at the notation for the antiderivative that we met in the previous video and discuss a slightly different name for it. So if we want to find the opposite of differentiation, we use this sign. This is an integral sign. The opposite of differentiation we usually refer to as integration. So let's say that we want to integrate this function. Let's just look at this notation. So this is saying integrate this function with respect to x. Just like the dx when we was looking at derivatives, told us that we were differentiating y, differentiate y, and then we read the dx as with respect to x. Generally this won't appear to have much meaning in the AS year. However, in the second year we will have different variables in here and want to change one variable into another. Then that dx becomes very important as it conveys meaning. So please put it in this year, it will make more sense why we have it next year. Okay, so we want to integrate this function. We remember integration is just the antiderivative. So if we just call this the integral, then the integral would be add 1 to the power, divide by the new power. Remember, multiply by the reciprocal. Add 1 to the power, divide by the new power. 3 over 3 is just 1. Notice that I'm actually writing down what the x power would be and then doing my differentiation, my division. It just makes it much easier to do. Again here, we know that constants disappear under differentiation, but under integration, we can see this as having a sneaky little x to the 0 there. Now if I add 1 to the power, x to the 1, divide by the new power, 4 divided by 1 is still 4. So constants do not disappear under integration. They will just become 4x. But remember, I must have a plus c. When I'm integrating a function, there could have been a constant before I differentiated it, so I add that constant back in. On this occasion, I'm not given a coordinate, so I have no way of finding what that constant is. However, I have integrated it, and I must remember to plus c when I integrate.